Hello, welcome to Unit 5, Lesson 2. I'm Professor Blackman. In this lesson, we're going to be talking about rational expressions. We're going to talk about least common multiples, least common denominators, and how to add and subtract rational expressions. Down here, I have a reminder of how to add and subtract fractions. Remember, you just need a common denominator. The least common multiple is the factor that is found in both. And so it's the easiest way to find this is a process called prime factorization, which I'll be going over. All right, let's go ahead and get started. All right, so 18, if you take the number 18 and you break it down into prime factors, which is breaking down to its prime numbers, it breaks down to 2 and 9, 3 and 3. So 18 is 2 times 3 times 3. Then we're going to look at 24. 24 breaks down to 2 and 12, 2 and 6, and 2 and 3. So 24 is 2 times 2 times 2 times 3. So when we look at this, they have a 2 and a 3 in common. But this one also has a 3. And this one also has a 2 and a 2. So what we have to do is we have to make sure all those factors are found in our least common multiple. So that's 2 times 2, which is just in the 24. That is the 2 and the 3 that is found in both, and the 3 that is just found in 18. When we multiply that up, that's 9, 18, 36 times 2, 72. And so that gives us 72. So that is the smallest number that both go into. All right, let's look at these as factors. Well, 12 is 2 times 2, which is 4, times 3, which gives you the 12, times x times y times y. 15 is 3 times 5, times x times x times x for the x to the third times y. So let's see the factors that they have in common, which are x, y, and 3 are found in each one. But then separately, there is a 4, 2 times 2, and a y. And on this one, we have a 5, an additional x and x. So when we go to write that out, we have 2 times 2, which are from the yellow, times 3 times 5. So that's the 3 they have in common and the 5 that's just found in the green. And then we have 1, 2, 3 x's, because we have the 2 green plus the blue they have in common. And then we have y times y. And so when we multiply all that out, that's 15 times 2, which is 30, times 2, which is 60. And then x to the third, y squared. And so what's great about this is when we get in, we need to figure out how to multiply to change it. If you multiply the 12xy squared by the 5x squared, which is all in green, it will give you this. Or if you multiply the 15x to the third y by what's in yellow, the 4y, it will make it equal this. All right, let's look at some more examples. All right, so now we're going to do that with polynomials. And so here, we're going to factor the first one to x plus 1, x plus 1. The second one is difference of squares, so that's x plus 1, x minus 1. And the third one here is 3x, x minus 1. And so now we can see what they have in common is we have an x plus 1 that's there, and we have a x minus 1 that's there. But then we have these additional ones that here and here, which aren't represented, are only represented once. So we just need to make sure that when we're writing it out, each one is counted. So the 3x, the x plus 1, x plus 1, and x minus 1. And it's fun to draw the arrows because you can see, okay, that's there, that's there, that's there, that's there, that is there, and that is there. And so you can see that everything is counted. All of this is the LCM of everything that's listed. All right, so first one is x plus y, x minus y, because that's difference of squares. And next one is, we're going to have to rearrange it first, because that's negative 5x, because the first one had x first, so we need to make sure the second one has x first as well, plus 5y. And so leading term is negative, so negative 5x. Negative 5 is going to be factored out, and we have an x minus a y. And so now we have negative 5, x minus y, which is found in both of them, and x plus y, which is only found in the first one. All right, let's look at some more examples. Okay, so we're going to add fractions, and the first thing we need to do is make sure we have a common denominator. In both these examples, they have common denominators. So then it's just going to become x plus y over x minus 2y plus x plus 9y. And so that will give us 2x plus 7y over x plus y. Okay, let's look at another one. Now, one of the things that I do with my subtraction problems is I always make them addition. So I will go ahead and rewrite this as 4y minus 3 over y minus 2 plus, now what I'm going to do is kick that negative up and now make it a negative y plus 2. A lot of people forget to apply that negative to everything, and so by doing that, it's already been applied and now it's just addition. So now we have all over y minus 2, we have 4y minus 3 minus y plus 2. And so now when we simplify that, we get 3y minus 1 over y minus 2. All right, let's look at another example. All right, so in this example here, you can see that our denominators are not the same. But we know that this will factor to x plus y, x minus y. So we have x plus y here, so what we need to do is we need to take and multiply this by x minus y and x minus y. So that way they have the same denominator. So we'll have 4xy over x plus y, x minus y, and then on top, distribute, we get x squared minus xy minus xy plus y squared. And then we're going to simplify that. We get x squared, 4x minus xy would give you plus 2xy plus y squared, all over x plus y, x minus y. Now, a lot of times you'll be done here, but you always need to check to see if the top also factors. It does. That's a perfect square there. So that will become x plus y on top. And on bottom, we have x plus y, x minus y. And then you can see that we have factors that can cancel. And then that will simplify to x plus y over x minus y. All right, so here we can see that this factors to x plus 1, x minus 1. So we need to make sure that this one on the left has an x minus 1 multiplied by top and bottom, and the one on the right is multiplied by x plus 1 on top and bottom. So I'm going to go ahead and write it all over x plus 1, x minus 1. So this one on the left needs to be multiplied by x minus 1. The middle stays what it is. And the right has an x minus 1 on the bottom, so it needs to be multiplied by x plus 1. And then let's simplify that, and it becomes 4x minus 4 plus x plus 2 plus 3x plus 3 all over x plus 1, x minus 1. And so now we have 4x and x, 5x, and 3x gives us 8x. Negative 4, 2, and 3 give us a plus 1. And that will be over x plus 1, x minus 1. All right, let's look at another example. Okay, so here we need to figure out what's in our denominator. So I'm going to factor out a 3, and we get x plus 5. This one I'm going to factor out and get x plus 5. So when we're looking at our LCM for this one, it would be 15x plus 5, because 3 times 5 and the x plus 5 is shared. Now, as I mentioned before, I like to kick my negatives up. So I'm going to move this up and make this negative and this negative. So I'm less likely to make a mistake when I'm multiplying. So now I have on bottom, I have 15x plus 5. And so I need to multiply this side by 5 and 5. And I need to multiply this side by 3 and 3. And when I distribute that, 5 times x minus 1 would be 5x minus 5. And on this side, that's negative 3x. And a negative 3 times 3 is a negative 9. And when I simplify that, my denominator, of course, would always stay the same. 5x minus 3x is 2x. And negative 5 minus 9 is negative 14. And to put that in factored form, that would be 2x minus 7 over 15x plus 5. And nothing there can factor, so we'll leave it like that. All right, let's go ahead and do the same thing over here. I'm going to change that subtraction into addition. So make that negative on top. And now let's see, the left one factors to y minus 5, y minus 2. And the right one factors to y minus 5, y minus 3. So my LCM for this one, or LCD, would be y minus 5, y minus 2, y minus 3. So I need to multiply this left side by a y minus 3. And I need to multiply the right side by the y minus 2 that is missing. And so that will give me, I'm going to just rewrite it as 3y, y minus 3, minus 2y, y minus 2, all over y minus 3, y minus 5, y minus 2. And so when I distribute that, I get 3y squared minus 9y minus 2y squared plus, negative times negative is positive, 4y, all over the three binomials, y minus 3, y minus 5, y minus 2. And then I'm going to look at my, simplify the top. So I get 3y squared minus 2y squared would be y squared. And negative 9y plus 4y would give me a negative 5y. And on bottom, y minus 3, y minus 5, y minus 2. And then that would simplify to factor out a y, and you get y minus 5, and then you have y minus 3, y minus 5, y minus 2, which now you can see that the factors on top both have a matching factor on bottom, and that would become y on top, y minus 3, y minus 2. All right, let's look at another example. All right, so now we're going to add and subtract. So in this problem, I'm going to start by taking my negative and moving it up to the top. So I have both of those changing to negative, and then I need to figure out what my factors are. Well, this factors to x plus 2, x minus 2. So that means I need to multiply this first one by the missing x plus 2 by top and bottom. And I need to multiply the second one by the missing x minus 2. So now I have x plus 2 times x minus 1 plus negative x minus 1 times x minus 2 plus x minus 6. And all of this is over the denominator, x plus 2, x minus 2. Because that's what my least common denominator is. And so now that they're all there, I can multiply this out, and I get x squared minus x plus 2x minus 2, and then negative x squared plus 2x minus x plus 2 plus x minus 6. And all of that is over x plus 2, x minus 2. And then I'm going to simplify the top. Well, I see a negative x squared and x squared, so that's going to cancel out. And I have a negative x here and an x here. That's going to cancel out. A negative 2 and a positive 2 are going to cancel out. And now I have a 2x, and a negative x. So that's a 3x. And I have a negative 6. All of that is over x plus 2, x minus 2. The top has a common factor that can be pulled out. Factor out that 3, and you get x minus 2, x plus 2, x minus 2. And you can see that there is a factor that's on top and bottom that can be canceled out. And that leaves us with 3 over x plus 2. All right, let's look at our final example. So here, same thing. We're going to look, and in this middle one, we're going to find the y plus 4, y minus 4. So I need to multiply this one by y plus 4 on top and bottom. And I need to multiply this one over here by the missing y minus 4 on top and bottom. So my LCD is y plus 4, y minus 4. And on top, I'm going to have y minus 4 times y plus 2 plus y minus 7, which I didn't do anything to it. And then I'm going to move my negative up and make that negative and that positive. And so that will give me plus a negative y plus 3 times y plus 4. So I don't have to worry about subtracting everything later. I applied it originally. So now I get y squared plus 2y minus 4y minus 8 plus y minus 7 minus y squared minus 4y plus 3y plus 12. And all of that will be over my LCD, which is y plus 4, y minus 4. And let's see what can cancel out. I got these y squareds that cancel out. Let's see. I think that's kind of it. And then I have a 2y and a negative 4y plus y, so that's negative y, minus 4y. And so that all gives me a negative 2y. And then with my numbers, a negative 8, a negative 7, and a 12 give me a negative 3. All of that over y plus 4, y minus 4. All right, that's all I have for you today. Happy studying.